Yeah, welcome to lesson 5, unit 1, matter and energy. We're going to talk about unit conversions today. We'll be doing the practice packet 13 to 14. We're going to convert units between units of measure. All right, with that, go ahead and open up your practice packet to page 14. You'll see conversion factors, and let's go through what we're talking about. Conversion factors are mathematical expressions that relate to units. So, for example, 1 minute equals, of course, 60 seconds. 1,000 grams equals 1 kilogram. And 1 liter, I think you recognize, is 1,000 milliliters. The idea is these prefixes, kilo, milli, change things in the metric system, but converting from one unit to another, that's the key idea here. For the regions, the most you'll have to convert will be between milli, kilo, and base unit, grams and liters. This is always a matter of 3 or 6 decimal places. So it's not like a ton of conversions. But you do have to understand them and how they work, and that's what we're going to do today. So 3 or 6 decimal places is all we're asking you to be able to manipulate. You also must make sure that the decimal is moving in the correct direction. So big numbers for small numbers. So if you have feet and you're moving to miles, the number will get smaller because you're using bigger units. So the movement of the decimal will help you move left or right. All right. I'm not going to do the trick because I don't particularly like the trick. So if you want to do it, that's cool. But you don't need to memorize these. You just need to know what kilo means. It means 1,000. Centi is 1 out of 100. It's 100th feet, and milli is 1 out of 1,000. If you remember this, it's fantastic because you can also then understand that kilo means 10 to the third. Centi is 0.01 or 10 to the negative 2. And milli is 0.001 or 10 to the negative 3. All right, I think that is the best way to look at it. Let's practice. All right, a car travels 845 kilometers. How many meters is this? All right, so what you want to recognize is that you have 845 kilometers. Now notice how I'll set this up. I want you to recognize that for every, we're going to need to multiply by the conversion factor. And in this case, the conversion factor is there's 1,000 meters for every kilometer. Now, mathematically, you might remember that units that are on the opposite side of a division bar cancel, and you're left with the unit that's on the top. So when you multiply this, you'll get 845,000. Now, you don't even need to think about this too much. The reason I say that, the reason I say you don't have to think about it too much is that they want to know how many meters, and if you recognize kilo means 1,000, I hope you recognize that means you add 3 zeros to 845, and here's the 3 zeros, so 845,000. All right, convert this number of liters to milliliters. Since we're using smaller units, we expect this number to grow. We know milli means 1 out of 1,000, or 10 to the negative 3. What I want you to think when you do this is that you're going to move the decimal over 3 places. 1, 2, 3. So it will be 29 milliliters. How about milliliters to liters? Now this is going from small to big, and so the idea is there will be less numbers here, and how many units is milli? 10 to the negative 3. So that means we're going to move the decimal over 3 places. So it's going to be 2.5 liters. This is using logic, and hopefully you understand the process. Try this for each of these, and then unpause the video. If you don't understand it, just keep the video playing until you sort of get the hang of it. And then when you get the hang of it, please pause it. That helps. So 3 grams is a small unit. Kilograms is a large unit. So this number will get much, much, much smaller. Okay, just like the 2500 going from small to big. So small number, big unit, small unit, big unit. The difference will be 1,000. That's 3 decimal places. And so I'm going to add to move this over 3 places. 1, 2, 3. 0.0. Notice how there's 1, 2 zeros in front of the 3. 0.003 kilograms. 1 kilometer is how many meters? That's right from the conversion table. 1 kilogram is how many grams? Remember, kilo means 1,000. So it's 1,000 grams. Hopefully you're getting the hang of it. If you are, go into it. How many milliliters? 1,000 milliliters. 7 meters. Well, you know there's going to be a lot of them. So there's going to be 1,000 for each one. For each meter, there's 1,000 millimeters. So 7 meters is 7,000 millimeters. 12 milliliters, we're going from small to large units. So this number is just going to get smaller and smaller. And it's going to be smaller by a factor of 3. So you'll notice I'll need 1 0 in front of there. 56. So just tell us which one is bigger or smaller, or if they're equal. 56 centimeters, 6 meters. Well, if you know in 1 meter there's 100 centimeters, 56 centimeters isn't even close to 1 meter, so it's certainly less than 6. 7 grams versus 698 milligrams. All right, so it takes 1,000 milligrams to equal 1 gram. So 7 grams is way bigger than 698. Once you get your answer, check it. And does it make sense? I've been doing that throughout, so hopefully that makes sense of how to do that. Accuracy versus precision. So with accuracy, it's you know what? I might try something. I'm not sure it will work. I'm going to try. I don't think it will work. Okay, that's fine. I tried it. What I was doing is didn't type in the answers. What we're doing here is accuracy is how close you get to the actual desired value. And it's your results that we're talking about. So your measurement on the ruler, so if we already know and we're fairly accurate, we'll be pretty close to it, our desired value. Period. Okay, so hitting a bullseye when you're aiming for it, so that means you're pretty accurate. For most experiments, accuracy, or to be accurate, means you're within plus or minus 5% from the expected value. Precision, though, is a little different. It means that you're measuring it to the very exact metric. So whatever units you're measuring to, so you're measuring to the millimeter. But it also means how close you are to your other results. So how close they are to one another. And if you are really close, it means you're very repeatable. Can you be precise but not accurate 100%? So if you were aiming for a dartboard and your results were always right over here, this is very precise. You were very close to each other. You were within an inch, but you were not very accurate. To be accurate, I wonder why. Anyway, if your results were here, here, and here, you were both precise and accurate. Yeah, so just remember, precision is about consistency. Oops. And grouping. For an experiment with plus or minus 10% is the margin for accuracy. That means the difference between the highest and lowest values can exceed 10%. Well, they cannot exceed 10%. So if I weigh 120 kilograms and I'm measuring a scale and the scale says it's within 5%, that means it can be 5% above or 5% below, but it can't be beyond that, and that range is 10%, if that makes sense. If the highest percent error for an experiment is 7.6%, and the lowest is negative 5.4%, and that range is 30%, which means the experiment was not precise. Okay, here's an example of some darts thrown by some players, assuming that they're all aiming at the bullseye, which target with a proper description. All right, so for this one, what did they want? Assuming that each one. Okay, so what do we call this first one? Cheryl. Was she precise? No. Was she accurate? No. She was neither precise nor accurate. Oh, sorry. Neither precise or accurate. So she's option D. How about Cynthia? I like her accuracy. I got to be careful here. Her accuracy. Precise but not precise. Piece of data. Accurate. They're a little bit specific here. I like accurate and precise. This is the best one. This is the accurate and precise. This is, I was hesitating on saying this is precise, but it's not too bad. It's just a little bit out of it. It's certainly better than Cheryl. And accurate, she's closer than Cheryl again. So I'm leaning towards C, but I'll leave that up to you guys. I'd accept A or C on that one. And it says one piece of data is accurate. I think that's what it's meant to be, but it's fine. Over here, this was high precision, so that's really great, but not very accurate. The following data was collected using a lab experiment. The density of the cube is 10.8 grams per milliliter. Is this data correct, accurate, precise, or both? Justify your answer. All right. So when we look at this, we say the actual amount is 10.8 grams per milliliter. And what's the resulting error here? All right, one of the things you'll see here is you'll have the measured value and the observed value, or in this case, accepted value. So we'll call this accepted. And these are the measured value. Keep that in mind because we're going to use a formula you might have seen before. It's called the percent error. And percent error will tell us about how we can look at how far away and how precise and accurate. It's measured minus accepted over accepted. All right, and so we know the accepted is 10.8, so we just take these values. For example, 6.2 minus accepted is 10.8. And divided by our accepted value of 10.8. And when you look through these, the most accurate, oh, by the way, when you get this answer, you're going to multiply by 100 just to convert it to a percent, right? When you get this answer, you'll see the most accurate one is this one, 6.8, for example, and if I did the math here, it would be 10.8 divided by 10.8, we should get 0.398 negative, and that changes to 39.8%. We multiply by 100. Okay, so to show you how I got that, that's the most accurate result. And even with the most accurate result, there was a negative 39.8% error, which is not good. Well, I'll say in this context for sure. Now the range, so it is therefore not accurate. However, all of these values are within 2.8% of each other. All right, so they don't move very much. So I will say in this data, it is precise. But not accurate. All right, and that's how you interpret data. Not easy, not hard, it's just part of the thing. All right, and we were going to just page 14, so let me make sure we got that done. Oh, we're going on page 15, nice. That is what I wanted to do anyway. I have to change the thing. All right, so good, accuracy and precision, we covered that. Let's take a look at your homework or the practice packet that you'll be working on. Unit conversions you've already done. Let's try one of these. And yeah, how many milliliters are there in is there in 21.5 liters? Okay, we've already done this, but sorry, just thinking how many milliliters there are. So let's take our number 21.59 liters, and we're trying to convert it to milliliters. So we're going to have a lot more of these. And how many? Well, you have to remember milli means there's 1,000 milliliters in 1 liter, so we're going to have to multiply it by 1,000. So I did write the equal sign. What I will do is just show you I'm going to multiply by 1,000 here. It says show work here. And so that means I'm going to move the decimal place over 3 places. 1, 2, 3. And that's how many milliliters we have. All right, hopefully that helps. All right, next one. Convert 1.62 meters. This is a large unit to a very small unit. And so to do these, remember, we're going to get a lot more centimeters because every centimeter has 100 centimeters in 1 meter. You might already guess what it would be. If there's 100 centimeters in 1 meter, there's 162. So we take 1.62 meters times 100 because there's 100 centimeters. And that equals 162 centimeters. I think that's it. Any other confusing ones here, you just let me know. Let me show you a technique I showed you in class. One more how to do this. 10 liters to its equivalent milliliters. So if we have 10 liters and we're converting it into milliliters, you'll notice how I'll write the liters on the bottom, the milliliters on top, and then I'll write the conversion factor. How many liters in a milliliter, how many milliliters in a liter. So to recognize there's always small units, so there's in large units, so 1,000 milliliters. You notice the liters cancel. And that means 10 times 1,000 is equal to 10,000. And the unit is milliliters, because mathematically that's what's left over. All right, is there any tricky ones here? Nope, I think we're all set. All right, guys, thanks for your hard work. Good luck.